Alright, Dave again here with another question from your Hayes & Harris Math SL textbook. This is chapter 3E.2, question 2D and 2H. And in both of these questions, we're going to be factorizing an expression with a variable in the exponent. What we're going to be looking for here is a form of factorization that we're familiar with. In this case, I see difference of squares. I see one square take away another square. 25, you probably recognize, is a square. It's 5 squared. 4 to the x might not strike you as a square, but it is, because 4 is. 4 is 2 squared. So I can replace the 4 with 2 squared. I still have the x out here, though. Not quite the right format for difference of squares yet, but we can get it there. We'll leave the 5 squared alone. 2 squared to the x using index laws is 2 to the 2x. But because 2 to the 2x is the same as 2 to the x times 2, like 2 times x is the same as x times 2, I can also write it as 2 to the x squared. So 2 squared to the x and 2x squared are the same because they both simplify to the same term. 2 times x is 2x and x times 2 is also 2x. So this is 5 squared take 2x squared, which is difference of squares, which means factorized it's going to be 5 take 2 to the x times 5 plus 2 to the x. Taking a look at part H, again we're looking for familiar forms. Very first thing I notice is this same 4x, which I can take advantage of in the same way. That's going to be 2 to the x squared. So that's something squared. 49 is something squared too. It's also 7 squared, so I have squares. 2x squared, 7. Here's a 2x, there's a 2x, here's a 14, there's a 7. Oh, but what do you know? 7 goes into 14 twice. So that's 2 times 7 times 2 to the x. And this is perfect squares. I have 2 to the x squared, 7 squared, 7 2 to the x times 2. That gives me 2 to the x take 7 squared, just utilizing perfect squares.